Hello, in this video we will be discuss about the preparation, important properties and main uses of oxalic acid. We know that the oxalic acid has the molecular formula COOH, that is C2H2O4. The structure is COOH, and the IUPAC name of this oxalic acid is ethane dioic acid. Here first we consider the methods of preparation of oxalic acid. The first method is from ethylene glycol. Ethylene glycol undergo oxidation in presence of concentrated nitric acid. We will get oxalic acid. So this oxalic acid can be prepared by the oxidation of ethylene glycol with concentrated HNO3. The second method is from cyanogen. Cyanogen undergo acid hydrolysis. We get oxalic acid. That is, oxalic acid can be prepared by the acid hydrolysis of cyanogen. Then third method, from cane sugar. Cane sugar means sucrose. Sucrose undergo oxidation in presence of concentrated nitric acid. We will get oxalic acid. That is, this oxalic acid can be prepared by the oxidation of sucrose with concentrated nitric acid. Here we can use for speed up the reaction. We can use vanadium pentoxide as the catalyst. We may use vanadium pentoxide as the catalyst. So this sucrose can be oxalic acid can be prepared by the oxidation of sucrose with concentrated nitric acid in the presence of vanadium pentoxide as the catalyst. Then the fourth method, from sodium formate. HCON, that is sodium formate. Sodium formate first heated, we get sodium oxalate. That is, sodium formate when heated about 375 degrees Celsius, there is elimination of hydrogen molecule. There occurs elimination of hydrogen molecule. We get sodium oxalate. Then this sodium oxalate then treated with calcium hydroxide, CaOH twice. We get calcium oxalate. Then followed by the treatment of this calcium oxalate with sulfuric acid, dilute sulfuric acid, we get oxalic acid. And calcium sulfate as byproduct. So here first sodium formate is heated about 375 degrees Celsius, then followed by the treatment with calcium hydroxide, we get calcium oxalate. Then followed by sulfuric acid, followed by the dilute sulfuric acid treatment, we get oxalic acid. So here the sodium formate is heated at about 375 degrees Celsius to get sodium oxalate. This is converted into calcium oxalate by treatment with calcium hydroxide and then acidified with this hydrosulfuric acid to get oxalic acid. Oxalic acid. Generally, this oxalic acid is obtained in the form of solution. The solution, oxalic acid solution, is concentrated and cooled to get crystals of oxalic acid. So these are the main methods which is used for the preparation of oxalic acid. First one, from ethylene glycol. Ethylene glycol undergo oxidation in presence of concentrated sulfuric acid. Ethylene glycol undergo oxidation in presence of concentrated nitric acid. We get oxalic acid. Then second method, from cyanogen. Oxalic acid can be prepared by the acid hydrolysis of cyanogen. Then third method, from cane sugar. Oxalic acid can be prepared by the oxidation of sucrose, that is cane sugar, sucrose, with concentrated nitric acid in the presence of vanadium pentoxide, V2O5. Here V2O5 is the catalyst. Then last method, from sodium formate. Sodium formate is heated about at 375 degrees Celsius to get sodium oxalate. This is converted to calcium oxalate on treatment with this calcium hydroxide, and it is followed by the acidification with dilute sulfuric acid. We get oxalic acid in solution. This solution is concentrated and cooled to get the crystals of oxalic acid. Next, the important properties of oxalic acid. First one, acidic character. Oxalic acid is one of the strongest dicarboxylic acid. It is a diprotic acid. Which ionizes two steps. So it forms salts. Salts with bases. Let us check an example. When oxalic acid is treated with a sodium hydroxide, first we get sodium hydrogen oxalate. That is, one of the COH group is ionizes, or one of the COH carboxylic acid group is reacted with this NaOH. We get sodium hydrogen oxalate. Then next, again this other carboxylic acid group is reacted with this sodium hydroxide. We get sodium oxalate. Similarly, when we treat this dicarboxylic acid, that is oxalic acid, is treated with ammonium hydroxide. We get ammonium hydrogen oxide, followed by then again reacted with this sodium ammonium hydroxide. We get ammonium oxalate. Here, when we stop or when we use little amount of ammonia hydroxide, the reaction generally stops here, and we get ammonium hydrogen oxalate. This ammonium hydrogen oxalate, when heated, we get oxamic acid. That is CONH2 COH. When we use this ammonium hydroxide in excess amount, we get this one, ammonium oxalate. This ammonium oxalate undergo, when ammonium oxalate is heated, we get oxamide. This oxamide, this CONH2 CONH2. So this is the acidic character. That is oxalic acid when treated with sodium hydroxide, first get sodium hydrogen oxalate. Again, this sodium hydrogen oxalate reacted with another molecule of sodium hydroxide, we get sodium oxalate. Similarly, similarly, this oxalic acid reacted with ammonium hydroxide. First we get ammonium hydrogen oxalate. Then this ammonium hydrogen oxide again reacted with another molecule of ammonium hydroxide. We get ammonium oxalate. When we heat this ammonium hydrogen oxalate, we get oxamic acid, that is this one, CONH2COH. Similarly, when we heat this ammonium oxalate, we get oxamide, CONH2COH2. Then second property, this reaction with PCl5, reaction with PCl5. This oxalic acid reacted with PCl5, generally we get these compounds, carbon dioxide, carbon monoxide and HCl. That is, this oxalic acid is just decomposed into carbon dioxide, carbon monoxide and HCl. When we use excess amount of PCl5, this oxalic acid reacted with this excess PCl5, we get oxalate chloride, that is this one, COCl plus 2 POCl3 plus 2 HCl plus 2 HCl. So when we treat this oxalic acid with excess amount of PCl5, we get oxalate chloride. Similarly, this oxalic acid reacted with this little amount of PCl5, or lower amount of PCl5. However, it is found that they undergo decomposition, and this is probably due to this formation of instability of this instability of its monoacid chloride derivative, that is this one, COCl. This is unstable, so it suddenly decomposes into carbon dioxide, carbon monoxide and HCl. Then third reaction, action with alcohol. Here this oxalic acid reacted with ethanol in presence of small amount of acid H plus. It may it is a concentrated acid. It is concentrated H2SO4. First we get monoethyl oxalate. Then this monoethyl oxalate again reacted with another molecule of C2H5OH. We get diethyl oxalate. So there, this action of alcohol. Here in the action of alcohol, first consider an example. Here first this oxalic acid reacted with ethanol, C2H5OH in presence of H plus. This here maybe concentrated H2SO4. First we get monoethyl oxalate. This monoethyl oxalate again reacted with another molecule of C2H5OH, ethanol. We get diethyl oxalate. Similarly, another example, this oxalic acid reacted with ethylene glycol. It is a diol. Ethylene glycol. We get ethylene oxalate. That is, this oxalic acid react with alcohols in the presence of small amount of acid H plus to form mono and diesters. This is monoester. This is diester. Mono and diesters. Then next one, action with glycerol. This oxalic acid with glycerol the reaction of oxalic acid with glycerol depends upon the temperature, reaction temperature depends upon the reaction temperature. When we treat this oxalic acid with glycerol around 110 degrees Celsius, first we get glycerol monoxalate, then it will converted into glycerol monoformate, again it will converted into formic acid. That is, when glycerol is heated with oxalic acid, crystalline oxalic acid at 110 degrees Celsius, formic acid is obtained. First this this reaction results glycerol monoxalate, that is this one, glycerol monoxalate. Then again there is an elimination of one CO2 molecule, we get glycerol monoformate. Then formic acid and 1 mole of glycerol. Simply we can say that when glycerol is heated with oxalic acid at 110 degrees Celsius, we get formic acid. Similarly, when we heat this glycerol with oxalic acid at around 230 degrees Celsius, first we get glycerol dioxalate. Again there occurs an elimination of 2 molecules of carbon dioxide. We get allyl alcohol. So the product of reaction with oxalic acid, reaction of this oxalic acid with glycerol depends upon the temperature of reaction. When glycerol is heated with crystalline oxalic acid at 110 degrees Celsius, we get formic acid. Similarly, when we heat this oxalic acid with glycerol at around 230 degrees Celsius, we get allyl alcohol. Then next one, action of heat. Oxalic acid, which is a dicarboxylic acid, have 2 carboxyl group are attached to each other. Here this in this reaction, that is, when we heat this oxalic acid directly, there occurs a decarboxylation. We get formic acid. This oxalic acid undergo decarboxylation when we heated around 175 degrees to 190 degrees Celsius to yield formic acid. So oxalic acid undergoes decarboxylation when heated at around 175 to 190 degrees Celsius to yield formic acid. Then next one, action of concentrated sulfuric acid. When we react this oxalic acid with concentrated sulfuric acid, and under a particular amount of temperature, or simply we can say that when heated with concentrated sulfuric acid, oxalic acid yields carbon monoxide, carbon dioxide and H2O. Just decomposes, or there's an elimination of water molecule, and simply we can say that there's a decomposition of this oxalic acid. So when we heat this oxalic acid with concentrated sulfuric acid, the reaction results carbon monoxide, carbon dioxide and water molecule. Then this one, next one, action with KMnO4 in acidic medium. Oxalic acid can be oxidized to carbon dioxide and H2O by the treatment with this potassium permanganate in the presence of an acid, generally H2SO4, at around 60 degrees Celsius. So, oxalic acid oxidized to carbon dioxide water molecule by this acidified KMnO4 at 60 degree Celsius. This reaction is quantitative and forms the basis for the estimation of oxalic acid by titration against standard KMnO4 or vice versa in the presence of dilute sulfuric acid. Actually, this reaction we have already studied. We have already studied this reaction in your previous class. We already done the titrations between this oxalic acid and KMnO4, that is permanganometry. Next, the main uses of oxalic acid. These are the major uses of oxalic acid. That is, oxalic acid is used as a primary standard in acidimetric and permanganometric titrations. This oxalic acid is used in the preparation of formic acid and allyl alcohol in the laboratory. It is used as a mordant in dyeing and calicoprinting. Similarly, it is used for removing ink stains from clothes. It is also used for removing rust from iron articles by reducing rust to soluble ferrous salts, and it is also used for preparing its useful salts such as ferrous oxalate, which is used in photographic developers, and potassium ferric oxide, which is used in platinum prints photography. So these are the major uses of oxalic acid. These are the major uses of oxalic acid. So these are all about the preparation and important preparations and important properties and important uses of oxalic acid.